sometimes you might see it. It's a norm for binary. And basically what we're saying here is that this x variable is represented by here. So it says find the expected, bit of a spelling mistake there. Find the expected value, okay? So what is the value that we're going to expect here? So the equation which you're going to get on your formula sheet is going to look something like this, right? Where it says the sum, right? The sum of x where x is equal to x. So what does that even mean? There's a lot going on there. So what that means is that if we take the very first example, we're going to say it's equal to x is going to be equal to 1. And then this is the probability, so we times it by that, 0.15. Okay, and then the next bit plus, because that's what the sum is, we grab the 2 and then do the same thing. So I'm going to draw it out all over here. So our e to the x for part A is going to be equal to 0.1 times by the probability, okay, plus 2 times by the probability at that point, which was the 0.35, and then you can kind of see the pattern here, right? So it's kind of like a weighted average, if you've ever heard of that before. So now we keep going and we can simplify each of these, okay? So 1 times 0.15 is 1.5, plus 2 times 0.35 is 0.7, and then 3 times 0.25 is going to be 0.75, and then finally we go plus 1. And let's add them all up. Okay, so this might be like a little bit tricky because there's so many numbers involved. So this is going back to your like addition, right? Your long addition. So I'd recommend writing it like this. Okay, and then you can start to add everything up. Okay, the 5s all add together and that carries the 1. Okay, 7 plus 7 is 14, plus 1 is 15, 16, and carry the 1. And this should be our average value, okay? So that is our final result. We can say e to the x here is going to be equal to 2.6. And that gives you the marks that you need. So the hardest thing is just understanding how that sum works. Okay, the next is write down the expression, if evaluated, that gives the variance of the distribution, okay? So we've got this thing here, right, where we've got a, like we're getting a variable x, and then we're going to times it by 5. So whatever value it is, we times by 5 and minus by 2. Okay. So what's super important, okay, is that we use the this equation here. Okay. So we're trying to find our variance of x, right? And that is equal to e when we square our variable x there, and then when we square the actual value there. Okay, so what we can do here is the one on the right is kind of easy because we've already got that value. We know that that is 2.6 squared, right? So we want to find the variance now, and so we've got that 2.6 squared. We can do some multiplication, but the next thing that we need to find gives us this e to the x squared there, where we're squaring each value inside. So it's basically the same thing as before, right? The same equations as before, except this time what we're doing for part B is that we say it's equal to the sum, right? So we're summing it up, and that x value we're just going to square, okay? But the probability all stays the same. So if we go through the same thing, 1 squared times by 0.15, and then plus 2 squared. 0.35, right? Okay, and then we keep on going, and we've got that 3 squared, and then that 0.25, and plus 4 squared, and then times that 0.25. So it's quite a lot of mental maths here, right? So let's break this down. This is all equal to, so 1 squared, that's the easiest. 2 squared is 4 times 0.35. So this portion here is just that 4 times by 0.35. And when we multiply that out, so again, you might need to do your long multiplication, but in this case, it's going to be equal to 1.4. So it's a pretty mental math heavy. The next one is going to be 9 times by 0.25, and that's almost like 10. So you go 10 times by 0.25 and then minus 0.25. That's the easiest way to do it, and that gives us 2.25. All right, and then finally we've got that 16, right? That's 16 times by that 0.25, and then that one, like you can imagine, it's going to be 16 times by 1/4, because that's what 0.25 is. So it's like saying 4. Okay, so now let's go ahead and let's add everything up, right? And so we're left with the 5s add together, that gives me a 0, carry the 1, so that's a 2, and 2 plus 4 plus 2 is 8, and then we've got a 7 here. So 7.8 is this e to the x squared. Okay, so we can take it back to this one, and we can say that this is really equal to, right? We can say that the variance of y, or the variance of our original equation, this variance here, is going to be equal to that 7.8 minus 2.6. Okay, and so that's the first bit. We're just going to ignore this transformation for now. That was my bad. So we're going to ignore that one for now. And you don't need to, I guess, go ahead and calculate that 2.6 because it just says write down the expression. But if you really want to, that 2.6 times 2.6, you can go through and do it on your calculator, even though this is a calculator-free question. So now this one says determine the expected value when we have y is equal to, right? And then this is the 5x minus 2. Okay, so what's nice and easy is that for every movement that we make, the expected value of a y is going to just be 5 times by e to the x, right? Minus 2. So super simple. Grab your value of 2.6 here and then put it in. So it's equal to 5 times by 2.6 minus by 2. Okay, really quickly, I'm just going to do it in pink because there's a lot of writing here on the screen. So that'll be, so I'll move it across actually, then we've got more space to work with. So we're trying to find our expected value of y, right? And because it's just a linear transformation, we can just use the same expected value because it just shifts the bell curve or whatever the distribution is, right? Like that minus 2, originally it comes from here, and our expected value is here, and we're just going to move everything by minus 2. And then we say times by 5, so then everything gets increased by, I guess, like times by 5. So it like gets stretched out in a way. So then that becomes times by 5. So what we can do is write this out and say 5 times by 2.6 minus by 2. And so that, right, the 5 and the 2.6, when we times them together, is 5 times by 6 is 30. And then 5 times by 2 is 10. And so then we're left with 13. So it's 13 minus by 2. Okay, 13 minus by 2, which is equal to 11. And that is your final answer for part C. Okay, so now let's go up to part D. Yes, there's quite a few here. So what would the number have to multiply to obtain the variance, right? So like, what number would you have to multiply to obtain the variance of y? So basically, what is, for part D, what is the variance of y? Okay, so we don't really, like, the variance is all about like the spread. So for instance, out of these two, this one has a smaller variance. The one on the right is a small, right? Small variance, whereas this one is a large variance. So what we do is we square it. And we don't really care if it's moved across because it's got the same spread. So in our transformation, this y is equal to 5x minus by 2. We can just ignore that bit. And then the trick is to say, what's the 5 doing? Well, it's timesing the x there. And so we can say that the variance here, right? The variance of y is equal to 5 squared by the variance of x, right? So that's 25. So for this question, you just need to say multiply the variance of x by 25. And that'll give you your marks. Cool. All right, so we're on to the next question here. And this is the continuous, like it's a new variable. So this is a new variable. I know it's given the same name, but it's a new variable. The continuous random variable is given by this. And so we've got a graph here, right, where it's like from 3 and it goes to 10, okay? And we don't know the value of k, but we know that it's a uniform probability distribution function. So in essence, all of this area in here needs to sum to 1, right? So it's a rectangle. The height times the width must equal to 1. So what we can say here is that the probability of 3 to, I guess, given this, must equal to 1. And so that's 10 minus by 3 to get the bottom bit, which is 7, times by k is equal to 1, right? And so then we say 7k must equal to 1, and we get k is equal to 1 divided by 7. And so you notice that quite a bit, is that k is always equal to 1 divided by something. Cool, let's go to the next one. So what is the probability here? Well, this is the whole thing, so it's just equal to 1. Okay, so the probability of 3 less than or equal to x is equal to 1 here because this is the whole thing. So what you can say is this, to get your 2 marks, I just want you to know that it's the whole probability there. So you can go 10 minus by 3 times by 1 on 7, and that is equal to 1. There's your marks. Cool. Now we've got plenty of other exam questions like this on our website. Don't get stuck doing the same textbook questions. These questions are a little bit challenging and are more likely to appear in your exams. So try them out. They've all got solutions and hints, and they've all got corresponding videos. But if you're still stuck, reach out to me. I offer in-person tutoring, online tutoring, or even group classes. So we'd be happy to help.